Alright, in this video we'll see how to calculate bonds price using Microsoft Excel. So what you have here, we have two bonds, bond A and bond B. And the key difference between these two bonds is that bond A is an annual coupon paying bond. That is, it pays coupon payments only once in each year, whereas bond B is a semi-annual coupon paying bond. So it will pay coupon payments twice in a year. And other information related to these bonds is also given. So let's see what you have for bond A. It has a par value of $1,000. So we'll receive $1,000 at the end of the maturity for this bond. And the maturity is 10 years. The YTM or yield to maturity or market interest rate could have also been given is 8%. Coupon rate is 7%. The 7% implies that the coupon payments that we'll receive each year will be 7% of this $1,000 or the par value. That is $70. So we'll receive $70 as coupon payments from this bond each year. And this coupon payments per year is again 1. Now what is the price? To calculate the price, we'll be using Excel's built-in price formula. To use this function, press the equal sign, then start typing price, then select this price function from the drop-down menu, and then you'll see that it takes several parameters like what is the settlement date, what is the maturity date, coupon rate, and so on. Now we need to get these parameters from the information in this box. So let's do it for bond A. The first parameter that this function takes is the settlement date. Now the settlement date is the date at which you buy the bond, and maturity date is when your bond gets matured. And our question doesn't provide us with any one of these dates, but it tells us that we have a maturity of 10 years. So what we can do, we can randomly set the settlement date to any date, and then set our maturity date as 10 years after our settlement date. Great. So let's set our settlement date to January 1st, 2020. And to do that, we'll be using Excel's date function. Press the equal sign, start writing date, now select the date function, and the three parameter it takes is year, month, and day. Year is 2020, comma, month is 1, day is also 1, close bracket, enter. Now the maturity date should be 10 years after the settlement date, that is 1st January 2030. So give that input, date 2030, 1 bracket, close, enter. Now the third parameter is redemption value. This is the percentage of the par value that we'll receive at the end of the maturity. Now our par value is $1,000, and at the end of the maturity we'll receive this full $1,000. Alright, we'll receive 100% of it, and in most cases that will be the case. So we'll just put 100 here. That implies that we'll receive all of the par value at the end of maturity. Then YTM, the yield to maturity, is 8%. So we can just manually put 8%. Or what you can do, you can press the equal sign and then select this cell. That will also do. Then the coupon rate is 7%. Finally, coupon payments per year is 1. Now let's calculate the price. So press equal sign, select this price function, and the first parameter is our settlement date. So select this cell, then press comma, then our maturity date is this cell, then again comma. This rate implies coupon rate. Our coupon rate is 7%, so select this cell. Then our yield is 8%, select this cell. Then the redemption, the percentage of par value that we'll receive is this cell. Now the frequency refers to the number of payments in a year. For annual coupon paying bonds, it is 1. You can manually type 1 here, or you can select this cell. And finally we have an optional parameter. This is actually the counting basis, day counting basis for Excel. If you keep it to 0 or don't put any value here, Excel will treat each month as having 30 days. But if you put 1 here, it will consider the actual number of days in each month and do the calculation on that basis. We can use just 0 here. We are fine with 0, so put 0 and close bracket, then enter. And as you can see, the price is this. Let's round it to 2 decimals. What we'll do, I'll select this cell and go here and go to number, keep these decimal places to 2. Now let's say 4, and then press OK. And our price is $93 and something. Now this is the price per $100 par value, but our par value was actually $1,000. Now to convert it from $100 par value to our actual par values price, what we'll do, we'll multiply this price for $100 par value with 10, because 1000 is 10 times of 100. Press enter. So our bond's price should be this. Great. Now let's do the same thing for bond B. Bond B settlement date, I'll just copy this. It has a maturity of 20 years, so I need to change this to 2040, and redemption value is again 100%. Then YTM is 5%. Coupon rate is 7%. Coupon payments per year is 2. Alright, now to calculate the price, again start typing price, then select this price function. Then our settlement date this time is this cell, maturity date is this one, coupon rate is 7%, yield 5%, redemption again 100. Now one thing, I most probably haven't used this cell, because if I did, then this cell would have been colored. So I've definitely done something wrong here. So what I'll do, I'll start giving those inputs again. Settlement date is this cell, maturity date is this one, rate is this one, yield is 5%, redemption is 100%, and finally frequency is 2 because it's a semi-annual coupon paying bond, and we'll keep the counting basis to 0, close bracket, enter. Now this time our price is 125.10. Now we don't need to any more conversation here like we did for the previous one, because we had a different par value than 100. But when your par value is $100, this is your actual price. Alright, that was all for this video. See you in the next one.